aquifer systems underground. A lot of carbon dioxide will be absorbed in the photosynthetic process. The climate will be cooled and the water balance regulated, and then we can expect to have after that more even and regular climatic patterns than we are experiencing today. And all this is due to the lack of understanding of temperature in relation to water movement and water behavior. There are certain relations between water quality and the human immunity. In the same way, there are relations between temperature and the immune qualities of water. Both blood and water fulfill the same function. They supply, on the one hand, the body earth with nutrients and elements so that it can grow and develop, and on the other hand, in our own body, it does the same thing. And these abilities are very much temperature dependent. But first we'll discuss water, because this also applies to the body. So anything really that I say about water also applies to blood, and it applies to sap and the movement of sap in trees. Water has its greatest density at its anomaly point of +4 degrees. It has to be maintained at this temperature for as long as possible, because this is a temperature which allows water to shift material. It allows water to grind up rocks, for instance, on its passage down a river, which then are supplied to the environment through which it passes. The coolness allows for the removal, transport of sediment, which is also which needs to happen in the blood, in the body, because the blood has to take waste matter and take it away. If the temperature relationships in the blood are not correct, then things like varicose veins and sclerosis and so on happen, because the blood isn't in a position energetically anymore to shift the material. The same applies to water. Now, water has, of course, its content of oxygen, and oxygen, as we all know, is always present at growth and also in decay. And whether it is active in one or the other spheres depends on the temperature. And in water, this crucial, what you might call changeover temperature, is at 9 degrees. Below that, the oxygen is, so to speak, bound by the water and is it's passive, and it goes towards the creating of high-grade microorganisms beneficial to life. Once water rises above that 9 degrees, then it gradually becomes more aggressive, and it enters an energetic level which is, so to speak, in harmony with parasites and bacteria, and then fosters their growth and development. And that is why it's very important in terms of the way we transport water and we move it from one place to another, that it should always be able to cool itself. It should be able to breathe, because as a living substance it must also be able to breathe. And in our modern world we seal it up in concrete or steel pipes, and gradually the water suffocates, and its oxygen content gets totally burnt up. Water has to be handled with great sensitivity. It is a substance which is alive. It has to be treated as something alive. Therefore, it should not be exposed to excess heat. It should not be exposed to excess pressure. All those things we know in our human body are destructive. And the same thing applies to water. There are two forces acting in any flow of water. That there is the force of gravity, which flows from the source down to the sea, and there's the force of levity, which flows from the sea back up to the source again. And the trout responds and is able to manipulate the forces of gravity and the forces of levity in order to maintain its station in flowing water. The extraordinary thing is that when a trout is startled from its lair or where it's reposing, then it accelerates upstream with extraordinary velocity, using the force of levity to move itself upstream. Victor Schauberger found himself in a very high alpine virgin forest, which he frequented so often, and in which he found the most extraordinary events. He came across them. It was though he was almost ordained to be there at the right time in order to perceive them. He came across this fast-flowing upland stream in which there was a trout, one of these stationary trout, just with a very slight flick of its tail, was standing in this rushing water. And apart from its station there, which of course made him ask the questions of how it was able to stand there and so on, he knew that about a kilometer downstream there was a waterfall, a very high waterfall, where the falling water atomized into mist. And so how was it possible, he asked himself, that this trout managed to get to this spot? Because they always come back to their spawning grounds to breed again. And from these sort of insights he evolved the idea of this interaction of two energies, of this gravitational movement from the source to the sea and from the sea back up to the source again. And the trout uses the levitational force in order to surmount these waterfalls. And it circles down at the bottom of the waterfall until it finds this upward vortex and then throws itself into the vortex, which then sucks it up and eventually ends up on the upstream end of it. Victor Schauberger decided to test this out. Victor had asked some of his foresters to boil up a cauldron of about 100 liters of water about 150 meters upstream. And on his signal, they poured the water into the stream. And as soon as the water hit the stream 150 meters up from where the fish was, the fish started to flail its tail as hard as it could and went backwards. Something had been cut in the water. The energy, which was the levitational force, had been destroyed by heat. Levitational force is the bioenergetic force, the biomagnetic force. It is the life force. And Victor observed these moss tips. The moss tips pointed up against the stream, against the current. But when the water was heated up through deforestation, then the moss tips pointed downstream, although because the water had heated, it was less dense than it was before. So he regarded these tips of the moss as being an indicator, indicating the health or disease of a stream. There is also another process by which the trout enables itself to stay in the fast-flowing water, and that is through the difference between the speed of the water as it flows past the trout's body and trout's breathing itself. According to Victor Schauberger, every particle of water is associated with a particular velocity and a particular temperature. And if the temperature relative to that velocity is exceeded, then turbulence automatically occurs. So in the terms of the trout, it's sitting with its body in the center, the coldest core water of the stream. And as the water filaments approach the body, they get squeezed aside by the body and in the process accelerate. And as they accelerate, they exceed their specific velocity relative to temperature, and turbulence occurs on the rear flank of the trout, which acts so it actually propels the trout upstream. The trout breathes in, or at least it takes in water through its lungs, extracts the oxygen from the water, or a large part of it, which then that water passes out through the gills in a semi-oxygen deficient state. And as a result of its lack of oxygen, it absorbs oxygen from the surrounding water and expands. And this expansion is also pushed on the back of the trout, which squeezes it forward like a bar of soap. When it wants to accelerate, it flaps its gills very fast, and that creates more turbulence. And also, because there is a greater expulsion of oxygen deficient water, that means there's a greater expansion of water behind it, which pushes the trout forward upstream. When we approach a new way of designing or a new way of looking at moving water, for instance, then we have